Most of the mass of all of the galaxies that we can see appears to be missing. It is believed that most of this mass is held in what's called a dark matter halo around the galaxy, and that galaxies in reality look something like this. But what is dark matter, and more importantly, why do we think that it surrounds galaxies like that? Put simply, dark matter is just matter that we cannot see or interact with except through gravity. We don't actually know what dark matter is, but the leading candidate is a class of particles called weakly interacting massive particles, or WIMPs. Two of the leading candidates for WIMPs would be neutralinos or heavy gravitons. But why do we believe that there's more to a galaxy than just that? Starting with the slightly smaller scale, you would expect that stars close to the centre of the galaxy would orbit the centre of the galaxy faster than stars around the edge. However, measurements have found that stars around the edge orbit the centre of the galaxy just as fast as stars close to the centre, and that doesn't fit with what we currently understand about gravity. This is actually an idea we've known about since before general relativity was a thing, when Kepler developed his laws of planetary motion. Next up, we have one of my contenders for coolest phenomenon in the universe, and that is gravitational lensing. Because galaxy warps space-time, light from distant galaxies can pass around a galaxy and reconvene at an observer. We actually understand how this works mathematically, and we can do equations to undo gravitational lensing when we observe it. When we use these equations to undo the gravitational lensing that we see here, we find that the amount of mass that we're having to add into these equations is more than the mass of the galaxy that is causing the gravitational lensing. In the even larger scale of the universe, galaxies don't tend to be isolated or random. They tend to cluster together in groups and look something like this. Galaxies move through these clusters faster than the mass that they have says that they would be able to do without breaking apart. Also, observing collisions of galaxies and galaxy clusters, we can see that the dynamics that we observe don't match the mass that the galaxies have, but require more mass than we can see. And finally, we have done computer simulations for the development of galaxies and galaxy clusters, and these simulations have shown that they actually need more mass than galaxies have to be able to get the results that we observe today. Personally, I think this fairly conclusively shows that we need dark matter to have the universe that we see today. This has been video 4 of my Galaxies series, so please make sure you're liking and following along so that you don't miss my next video. Thank you for doing everything that you do here, and until next time, I have been Dr. Alex Foden, the Science Wrangler, and I shall see you one of these days.